Okay. Then we have single channel undersaturated finite queue. This is still MM1. This is still MM1. So stochastic arrival, stochastic service, and one channel. Okay. The difference is finite queue. This one was for infinite queue. You see infinite queue. Okay, so if I start to have a queue, I have infinite space available to have the queue. Okay, this one is for a finite queue. Okay, so the queue is limited. I cannot have much space for queue, all that space for queue which I need. Okay, so in that case, again, the assumptions are already made for arrival and service rate. Their distribution assumptions are made, and then we have these equations. Probability of having n units in the system. Again, we are using rho again. Okay, so what is rho? Small q upon capital Q. Arrival rate upon service rate. Okay, expected number of vehicles in the system. Okay, and so on. Okay. So the number of vehicles that can enter the on-ramp of an expressway is controlled by metering system. Metering is like a signal. Okay, so it's not the meter which you see for electricity and so on. It's like a signal. Ramp metering means putting signal on a ramp. Ramp metering means putting a signal on a ramp. Okay, so signal is only red and green for the people who are on the ramp. We want to make sure that too many people don't enter the freeway at the same time, because they will block the flow on the freeway. So freeway is more important. So we put a signal and we call it a meter. So the length of the ramp can only allow up to 10 vehicles at a time. More than 10 vehicles and they will go behind the ramp and then they will block the other highway. Okay, so 10 vehicles can be at a time in the ramp. If the vehicles can enter the expressway at a rate of 500 vehicles per hour. Okay, so and the rate of arrival of the vehicle is 400 vehicles per hour during the peak hour. Then find out the following. Now what is this 400 and 500? Which one is small q? 500. 400. And then
500.
Okay, they can enter at 500 vehicles per hour. Okay, so this is a service rate at which they are exiting the ramp. So ramp is our system. Our system is a ramp. Okay. Find out the probability of 4 cars being on the ramp. Oh, sorry, 5. 5 cars on the ramp. Very easy, right? The first one. How much is rho? Small q upon capital Q. How much is this? Okay, then the probability for 5. Okay? 5. Which one? Where?
Should be 10, right? Because he said there are allowed 10 vehicles.
Would be maximum. What do you report as capital N? Give me the answer. 5?
5 or 10. As the
Capital N. 5? I'll check.
He said allow maximum 10 vehicles in one.
And if you put 10, what happens? Capital N is 10 then? I'm not sure, I have to check. I'm just saying. Yeah, put 10. But I will check it. I'll let you know. Huh? Okay, I will check for this. But for the time being, let us put it 10. For the time being. But I will check it. Because here it means number of channels. You don't have only one channel. Okay. The percentage of time the ramp is full. Full means 10. Full means 10, right? So how much is this? Okay. The last part, the expected number of vehicles on the ramp during the peak hour. So asking for this E value. If I give this question in the exam,
No, the exam.
what?
Because there is air conditioner in the exam room.
No, it will be here. You bring your own air conditioner.
I need to change it. So hard. Why choose this class?
To torture you. Huh? 9? Okay, so normally you will find around 3 cars on the ramp. So obviously you can see the percentage of time when the we have 5 cars is very low, because most of the times you are having 3 cars. Okay. So now we have another case where undersaturated finite queue, where the number of channels are now more than 1. Okay, so we have n number of channels. Okay. Again, for these equations, the condition is rho upon capital N should be less than 1. Okay. Rho, which is arrival rate upon departure rate, divided by capital N, number of channels, should be less than 1. Then these equations will work. Okay. So we have an equation for probability of 0 vehicles in the system. Probability of 0 vehicles in the system. Probability of n vehicles in the system when n is less than or equal to number of channels. Okay, so this equation, when number of vehicles in the system you are testing for is less than or equal to number of channels. If it is more, then you will not use this equation, you will use This one. Okay. Then we have this equation, which gives you probability of having n vehicles in the system which are more than the number of channels. Okay. Clear? Now what is the difference between these two equations?
This for a specific n.
This is for a specific value of n. This is for any value of n which is more than the channel. Okay? Right? So if you have 4 channels, you want to find out the probability of having 5 vehicles in the system. You will use this. If you want to find out the probability of having any number of vehicles more than 4, then you will use this one. Okay? What else? Average length of the queue, average waiting time in the queue, average waiting time in the system. Okay. So we have a toll bridge. Again, you have to pay the toll. There are 4 booths to collect the toll. Vehicles are arriving at 1200 vehicles per hour, and at the booth, drivers take an average of 10 seconds to pay their tolls. Okay. So the arrival rate, meaning which value is this?
Q small.
Small q. Okay. Then capital Q. I want capital Q. 10 seconds to pay for, or 10 seconds for one vehicle. 10 seconds for one vehicle. So how many in 1 hour?
6 times 60.
Huh?
6 times 60. 306.
360. Yeah, 360. Huh? 3600 divided by 10, right? So your capital Q is okay. Clear? Now when we had one channel, when there was one channel, so we were doing DD1, MM1, whatever, then the raw value what? 20 per minute. Converted to per minute, it will be same.
This value for the whole channel.
Yeah, total. Okay, so capital Q is 360. Okay, you can keep it per minute, you can keep it per second, but same. Keep it same. There's no problem. Okay, now the previous expressions we had, all the previous equations, MD1, MM1 case, we were assuming the raw value, raw is small q upon capital Q. Raw is small q upon capital Q. Okay, so we said this raw should be less than 1 for the previous cases, because in all the previous cases, how many channels we had? 1. Okay, so when you have one channel, to use those equations, the raw value should be less than 1. But now you have n channels. Number of channels are n. Okay. So to use the equations which I showed you in the last slide, then this should be less than 1. Not the raw. Raw can be anything. You can see here raw is
More than 1.
more than 1. Small q upon capital Q will be more than 1. Okay. But to use those equations, raw upon n should be less than 1. Okay. So in this case, how much is my raw? How much is it? Small q upon capital Q. Small q 1200, capital Q 360. If you are doing one channel case, then those equations will not work. Okay. But here you can still use them. So we have 4 channels, 4 booths.
3.3 or 5.1?
Yes. How much? Point?
0.823 maybe.
Okay, clear? So now they're asking for what? Yeah. How would the average queue length, time in the system, and probability of waiting in the queue will change if you have a fifth booth? Okay. So we have to calculate three things: average queue length, time in the system, and probability of waiting in the queue if we have a fifth booth. Okay. So they are asking for average queue length. Okay. Average queue length equation. Which one? This one. Okay. In this equation I need P naught. Okay. So first of all I have to calculate P naught here. Okay. Now I'm doing this to find out the change because of a fifth booth. Now I have 4. So I have to calculate all the values with 4 booths and then with 5 booths. Okay. To see the change. Okay. So give me P naught with 4 booths. So capital N will be 4 now. Rho is 3.3. What else do you need? Yeah.
Just go and see.
Huh?
You see.
Start from 0 goes up to n minus 1. So it's a summation. N is how much? 4. So NC will go from 0 to 3. When you put this as 5, then it will go from 0 to 4. Yes.
نسي هاي summation مرة تخليها 0 مرة تخليها 1 مرة تخليها 2 مرة تخليها 3
شلون؟
شلون summation يعني مرة تسمعها
ماشي ماشي
هو متعود
ينسي أو ينسي
Mm-hmm.
ينسي أو ينسي
NC or NC?
PNC or
Not P, raw.
raw, whatever.
Whatever.
There's
You will put 3.3, raw is 3.3, right?
Hmm.
Okay. NC will start from 0. So first of all, you will do 3.3 to the power 0 upon factorial of 0 plus raw NC to the power, raw to the power 1 upon factorial of 1 plus raw to the power 2 upon factorial of plus raw to the power 3
بس
factorial
مو
of
بس 2 مع تايمز 1 تايم في هذا مضروب
Yeah, no factorial.
factorial, you know.
No
Right?
factorial.
See, he did this. For what? P? For 4 booths? Okay. 02. Okay. And with 5 booths? No. You have to pass the course. No. You have to come to the class. No. You have to be a senior. No. You have to become engineer. No.
I have to be engineer. Doctor, how divided by 0?
Huh?
How divided by 0?
0 factorial is 1. Which one? This one, right? Or the other one? With 5 booths? With 5 booths? Huh? It will increase, yeah. 0.032. Okay. We have 5 booths, so the probability of having 0 vehicle in the system will increase. Okay. Next thing, why did we calculate? Because we want average length of the queue. Okay. So give me this now for 4 and 5 booths. So there is no summation here. Should be easier. Okay. Dawn, got it?
Yeah.
Okay, now do it. Huh? 2.6? And this one?
Here, Victor, the first one is not.
Huh?
Like for all, yes.
For
From 0 to 3. For
this one?
Yeah. And the front side.
He got the same answer, right?
And for Q,
Put here. There's no summation. You will just do it once.
okay.
It will be
Only
4
4.
3 4 into 3 into 2 into 4 again. So If you're doing it for 5, then so on. Yeah, because you increase the booth, right? So your queue size will decrease. Okay. The last one. Okay, pay attention. Pay attention. Probability of waiting in the queue. Okay. Everybody. Ibrahim, Abdulaziz. Probability of waiting in the queue. When will you wait? You have to wait in the queue. When the number of vehicles in the system are more than the number of channels. Okay? Only then the queue will be there, right? If you have 4 vehicles and we have 4 channels, there is no queue. Everybody will be to the channel directly. Okay? So when they say probability of waiting in the queue, they are asking for this probability. Okay? So now continue. Okay. So probability of P more than N. In the first case, N, capital N is 4, the second case, capital N is 5. Looking for this one. And this case, this one, huh? Now put capital N as 5 and how much? It should be less than 0.47 something, 0.13. Okay, so if you increase one booth, it will increase the probability of having no vehicle in the system by 1%. It will decrease the length of the queue by almost 2 vehicles. You see 0.59, this was 2.6. So here you have almost a queue of 3 vehicles. And here the queue will be only maybe 1 vehicle. Okay. The probability of having a queue is 47% here and only 13% here. Okay. So the 30% of the times you will reduce the times when they are the queue by 30%. More than 30%. Okay. When you had 4 booths, there was almost half of the chance that you will have a queue. And here you have only 13% chance that you have a queue. Clear? Okay? Okay, thank you.